Hello, hello, hello. Mr. Videographer, you tell me when to go.
You're good to go whenever.
1 more minute?
1 minute.
Yeah, there we go. We'll start on time.
Smile.
There we go. Come on. All right. Okay, we can get started, guys. It's the last day, so thank you for coming. Really appreciate this. My name is Adwait Joshi, and I am the founder and chief seer at DataSeers. To give you a little bit of background of me, myself, I've been in the data space. I've been a data geek for about 20 years now. That's why I went to school to study, and I've worked in a lot of different sectors. For the past decade, it has been financial services and everything payments. Gained a lot of expertise in this space and really started exploring data to the core. I have my Twitter handle up there, and the reason is because if you do decide to code, as I walk this through, you will find that there is a link, there's a bit.ly on my Twitter, and that link will directly take you to an IDE where you can actually code right in the browser and work with a data set that I've already uploaded. So let's start. So Hpcc systems, that's what I am talking about here. So to give you a little bit of a history, right? The platform was invented in early 2000, right? And it open sourced in 2011. So in some cases, this predates Hadoop. It was a very secret technology that LexisNexis acquired for close to $1 billion from a company called Sizint in Boca Raton. And you should read the story of the guy who started the company. His name is Hank Asher. And he went to jail for money laundering. He was actually moving money in his plane from outside of the country into the US, and he got arrested, and then there was a case, and he actually started this company and started using assets and data assets to put it together, and which basically today is LexisNexis. So if you actually have ever wondered, when they do a KYC on you and they check your data and they get all this information in a single place where here's your identity, here's your social, here's your date of birth, and here's your property records, blah, blah, blah. That's all Hpcc. They have several petabytes of data running in this engine, and it's super fast, fraction of a second, speeds to get anything done. The reason why Lexis bought this company back in the day was Equifax had a problem. They were trying to figure out if a credit card holder would default on their credit card payment. And it would take them 26 days to figure out if they were going to default that month. And so they had 4 days to actually send them a letter and go after them, right? Obviously, that didn't work. And when they ran that on Hpcc, it only took 6 minutes to run because it was invented from ground up. And they haven't spent a single dollar on advertising, right? So if Hortonworks, whatever they did for Hadoop, right? When Yahoo created that and moved it into a separate marketing company and they started selling it, that's what these guys should have done, but they don't, right? It's completely, totally free. And when I say it's totally free, it really is totally free. You can go to the website, hpccsystems.com, download the platform, start coding, training is free, application is free, and trust me, LN does not need your email. They don't even ask you for email names. They probably know who you are and what you're doing with the software anyways. There are some of the largest use cases are run on Hpcc today. So I'll give you a simple use case. I'm pretty sure you guys probably flew in here unless you're local. If you flew in here and if you went on Delta flight, when you're getting inside the plane in the door, look on the right-hand side. It'll have all these labels. And one of them says, we have been on time for the last X number of years. That actually is being tracked on Hpcc in real time. So they track the flight's status of whether they are in time, how much are they delayed and everything. They even had a very crazy thing where they put Fitbit on cows, and they were monitoring how much the cows were walking and their health in the agricultural industry. So the use cases are pretty amazing of what they have done. Obviously, Lexis being a financial services company, financial services is one of the largest use cases. And it's extremely fast. The integration, the processing, the reporting, it actually uses a very unique language called ECL. That's what I'm going to walk you through. But before that, let's understand a little bit of the anatomy of how HPCC systems works, right? So it is a big data engine. It is truly meant for structured, unstructured, semi-structured data. You know, if you look at court documents, when you go to Lexis to pull up court documents and they have people's names, or you go and pull up negative news and people have, you know, publications out there, that's all going into HPCC along with structured data, right? So it's all done with a single language called ECL, right? So that's all the developers will use VS Code and ECL and stuff like that. HPCC originally stands for High Performance Computing Cluster, but since then they just call it HPCC systems. There is two pieces to the puzzle, right? So the Thor cluster and the Roxy cluster. And the Thor cluster, as the name suggests, Thor is, you know, the guy with the hammer, and he beats the crap out of everything, so that's what beats the crap out of the data. And then Roxy, it's a very interesting name. It used to stand back in the day, 2000, right? Rapid Online XML something engine. So it started with all XML and obviously moved to JSON. But that's a data delivery engine. So think about indexing. So let's take the perfect example of if you're trying to pull up somebody's SSN and information off of their SSN, that would come from a Roxy because it's all indexed based on that SSN. You're looking it up, right? And then your predictive modeling, your data management, and everything happens directly through ECL. It does have a querying engine, a visualization engine, and all of that built in. And the beauty is, all of this runs on bare metal. So you can have a very tiny server or your laptop, and you can just run it on there. Again, goes back to the history. In 2000, you know, people were not using as much VMware that they use today, right? So what was happening was they started running it on the bare metal, let the entire operating system, you know, manage the memory and this and that. And this is developed in C++. So the entire code base of HPCC systems is on GitHub. So if you want to go look at what they did, how they did, and this is a 20+ years in development. And this is, honestly speaking, one of the largest data technologies in the world, meaning I have not seen any other technology house so much data. And you're talking 40+ petabytes of data that is used in production. Anytime any one of us opens up a bank account or anything like that, the data is coming out of this engine. So it's a very robust engine out there, right? So ECL. So ECL stands for Enterprise Control Language. One of the biggest things for developers you will see is we are all used to a specific type of language, whether it's JavaScript, whether it's, you know, Python or whatever. We write the code in order, and we expect the code to run in order. We also we write the code to exactly what we want to do. Here, it's a little bit different. So this is more of you writing the code declaratively, rather than, you know, you don't have to declare a variable, for example. You can just create a variable on the fly wherever. I don't have to explicitly declare it. I can just assign it, start using it. The other thing is, which beats people, is there is no loops. There is no for I equal to 1 to I equal to 10. Why? Well, what happens when you're working with billions of records? You're going to say for I equal to 1 to I equal to 1 billion I plus plus? No, that's not going to work. So they teach you to work with massive data sets, right? 10,000, 100,000, a million at a time. And so the language entirely is declarative and data-centric. So everything is manipulating data sets. And you have to almost unlearn whatever you know about technology or development and relearn a little bit of an ECL. So it's a little bit of an uphill battle at first, you know, maybe 7 days, 15 days, and once you get the hang of it, you kind of sort of fall in love with it. It's beautiful, and anybody can write the code. It's very forgiving. So what I mean by that is if you actually, here's an example. So when you do a join, you have a left data set and you have a right data set. And the way HPCC works is it expects the left data set to be the bigger one and the right data set to be the smaller one. Why? Because it takes the right data set and distributes it across its clusters. But accidentally, let's say you flipped it because you didn't know, and your left data set is small and right data set is big. The compiler looks at it and says, wait, I can actually do this better if I flip them. Your results are still the way they are, but those data sets are flipped, and it corrects your code. So it's very forgiving. So you can make a mistake, and it will actually correct. And sometimes you'll sit there and say, wait, why did that happen? And then you go to the explanation, and it tells you why it did what it did. So it's very forgiving from that perspective. And it's very different. So when you start looking at the code, at first, like I said, you'll not understand what it says, but once you look at it, it'll make more sense. So I'll dive into some of this. But before that, let's understand a very important concept of Hpcc. So in any big data engine, the key to doing whatever you're doing is to distribute your workload. So those are called as slaves. In this case, they're called as Thor slaves. So let's say I have a machine, and since you guys are developers, I'll talk some geek talk. So let's say if you have a 32-core machine, I can actually run one slave per core. So I can run 32 slaves. And if you have hyperthreading, I can actually run 64 slaves. What does that mean? If I have a 100 MB file, and when I quote-unquote spray it, it goes and sits into those 100 slaves, and it's distributed equally. And then the Thor master does the job of sending these little things across, right? And it basically uses a B tree to distribute the data, so it knows where to go look what. All of this is happening under the hood. You don't need to worry about any of that, right? But once you get into, like, we run our production loads on Hpcc, our entire company runs everything on Hpcc, and we have 50+ billion transactions, financial transactions that people are doing out there, and we have 1 billion accounts. And when we do our research, such as is John committing fraud, or is somebody trying to open up an account for somebody else, we have these massive clusters that run across the board and give us a result back in sub-second intervals. So the concept of spray is you take a file and you spray it into the cluster. And this is basically a UI, and I'm going to walk you through the actual coding. It can be any type of a file. CSV, flat files. If you guys have worked with financial services data, then it's very fun, right? You look at an 8583 message, it's pretty complex. You look at a 20022, it's pretty complex. You look at an ACH file, it's pretty complex. Or you just try to get into MasterCard's Hpcc format, the 7-bit format, right? You can't even open it in Notepad. It won't even open. So all those things you can actually process in Hpcc. And the reason was because it was their own use case. They had to do it. So they developed this from ground up. Record structure. So one thing in big data, right? So if you guys are computer science majors, one of the things when I did my class, course 101, and the guy hammered it on our heads that says strings are immutable, right? If you have done computer science, they have taught you strings are immutable. So everything Hpcc does is in two ways. It's either a string or it's a number. So there is anything that can be interpreted as a number will be interpreted as a number. So let's take an example of a date. Most people will look at a date and say it's a string because there is dashes in it. Well, you actually convert that into a number. You say 2020-08-19. It runs much faster because those numbers are, and you can just use an unsigned 4 because you're not going to have a minus 2020-08-19, right? So the key is making sure your record structures are defined accordingly. And it's required to read any data, right? So there is a taxi data set. I'm going to, like I said, if you guys came in late and you want to actually do some hands-on stuff, my Twitter handle is Adwait Joshi. I actually have a pinned tweet there that will give you a bit.ly link that will take you to the IDE. You'll need to create an account. It's free. And once you get in, you'll actually get the taxi data set that I'm talking about, as well as some sample code that I've put out there for you guys. So, if you look at the syntax, right, it's really different. And this is what takes the biggest challenge to get over understanding how the code is written. So in this case, DS taxi is nothing but a taxi data set, and I'm defining it as data set. I'm passing it a layout. Where is the file? And here's the funny thing. So you see training samples, : taxi, : out, : yellow trip data, clean.tor. If you go to the file system, there will be a folder called training samples. There will be a folder called taxi. There will be a folder called out. There will be a folder called yellow trip data. So this is actually sitting on the file system as it's there. Then I pass a layout, and I actually tell it what type of file it is. So in this case, it's a Thor file. And then you see obviously your CSV And with those 2 lines, it has read that entire file and given it to you in a nice format. So talk about a use case. When we get data from our customers, they hardly tell us what is in the file. Almost the spec never matches the sample files they send us. We don't even read the spec these days. We just run this and be done with it. We know within 5 seconds. And this can be done by a non-technical user the way we have implemented our system, right? So obviously, like any programming language, there are some basic functions like min, max, and count, and absolute, and then there's date functions, and there is string functions, and trim, and this and that. So now, when you talk about working with data sets, this is one of the most amazing things that blows people's minds away. So, and I'll show you an example of this. So when you get a data set, obviously some things, like sorting a data set or deduping a data set becomes very common. So, how cool would it be if you just had a word dedupe and your entire data set magically deduped? That's literally what ECL does. So when you say DEDUP and pass a data set, in this case, she's passing a lot more than just the name of the data set because you want to be more efficient. But you can literally say DEDUP DStaxi, and that entire data set will be deduped. And it will do a record-by-record comparison, and it will remove any duplicates. Now you can get more creative, and you can say, I want to dedupe just on these fields. And it will then dedupe on those fields, right? So obviously, and then if you have a, 100 million record data set that you're trying to dedupe, then you're going to get smarter, right? If the record set is sorted, it's going to be more efficient. If it is deduped locally, then it's going to become more efficient. So this one line dedupe that shows up here in 3 lines, the sort res, the local dedupe, and the global dedupe, right, is literally that. So when you start really working with the data set, there is no SQL. You have to almost unlearn SQL and do it differently. And once you start doing this, you'll really admire why it was developed this way. It was developed so that business users can write code, not developers. And so there is 2 concepts. There is a concept of a project, and there is a concept of a transform. So project is like a select statement. So when you say project DStaxi, I'm selecting from it, and then I can send filter by this, filter by that. And then transform is transforming the entire data set, right? It can be used in joins, and project, and iterate, et cetera, et cetera. There's all these little keywords, right? And then, here's another thing. So there is a concept of what we do in our data set. So I'll give you a simple example. So John opens an account today and gives me an address. Then he does all these activities over a period of time. But I want to know in that amount of time what his unique record was. Like, I just want to see one record, the most recent you call it or whatever. And there's a possibility that I received a bit of information 2 years ago, but then over and over again, when that data came in, it was missing. So I'll give you an even better example. So when you first opened that account, I had your social security number. But just because the nature of how security works, every time you change your address, they're not going to send me your social again and again and again. So I need to go back and look that up, right? So the concept of roll-up, where it actually compresses all of that data, goes back as much as it has to in order to pick the most unique value that it had in the most recent way. And why is this necessary? Because let me put it this way. So most people are used to doing CRUD operations, right, in data, which is the most common thing. Well, what if I told you that in ECL, it's only C and R? There is no U and there is no D. You can't update data and you can't delete data. That blows everybody's mind away. Why? Because the whole concept of something happened at a point in time cannot be changed anymore. It did happen. It was there. Now something else happened, but it's always going to have that memory of what happened before. I'm never going to forget, right? So that's how Hpcc operates. So you end up adding more and more data, and you use the concept of versioning. So what do I know? What is the most recent information I have? Well, I'm going to go by my most recent timestamp and say this is the most current information, and that's literally what happens in your identity. When you actually update your address and you try to pull up a record from Lexis, they're going to say this is the most recent information I have, but here's everything I know from before. I've not deleted it. It happened. I'm not going to get rid of it. So that's the whole concept of how the roll-ups work and so on and so forth. And table is something that's literally a table, right? So it says get required field. It's actually doing a table. It's taking the entire data set and just returning a payment type. That's it. And then it's running a sort on it, and then it's running a roll-up on it, and it's rolling it up by payment type. And guess what? It's actually then going to give you a unique. So it's like select distinct from a data set for that particular column. So it's a different syntax. There's about 6 things you need to know in ECL, and that's it. That's the whole thing. If you understood the syntax of those 6 items, you're done. Right? So when you're doing analysis of trends, right? So trying to get busy hours, or trying to get the most busy hour, right? Max and averages and this and that, all those mathematical things exist. But if you can see, the syntax is much different, and according to me, it's much cleaner. If I can get the busy hours in just one line of code, how amazing is that? I mean, and I'm searching millions and millions of records at this time, right? So if you look at what you can do in 10,000 lines of code, you probably can do in 10 lines of code in ECL. And what's really happening is that ECL is converting your 10 lines of code into 10,000 lines of code, because at the end of the day, this generates C++, and the C++ is executed on the machine. So, this data set is actually pretty interesting. This is a New York taxi data set, and I have uploaded about 5 or 6 days worth of data for everybody to play with. Because the way they explained to me, they said, talk for 30 minutes, let people get their hands dirty for 30 minutes, and then talk about what you just did for 30 minutes, right? So I uploaded about 5 days worth of data, and it has very unique, amazing things in there that talk about where was the pickup made. I mean, think about this as an Uber data set, right? And just before coming here, I wish I had known, a friend of mine just made several petabytes of data anonymized and available in financial services. It's a company in India called PhonePe. And they just basically democratized all of their anonymized data. So that's several petabytes of data that's available for people to use and play with. So that's going to be interesting. The other thing we do quite a bit is key value lookups, right? So obviously, we do that a lot, right? Simplest example would be if you look at an 8583 message, you're going to know whether the card was present or not present. And that's just a lookup. It's just either it was present or it was not present. Or let's say you used MaxStripe, you used Swipe, you used Tap, you used Token, all of that. Those are just lookups. What happens in this, right, in this case is when you actually use a data set like that, which is very small, it will then take and make that lookup on steroids. If you have 10 million records and you're trying to collapse that into one of those 5 values, boom, it will spread it out across the board. Like I said, the left-hand side stays the same, right-hand side gets distributed among the clusters, and then you literally run it. So these are some of the techniques more in detail of what other things you can use. Obviously, you have all machine learning libraries in ECL. You don't need to do anything. So one of the things we tell our kids when we hire them, they're Python developers. And we tell them that you can use Python, but it's going to be single-threaded, right? It's going to be a block when you try to run so much data. When you run it here, these algorithms, in fact, the guy that writes these algorithms, he lives about an hour out of Denver. And again, this is an open source project, so you can write it, you can extend it. And most of these machine learning algorithms are available for your use. And you can literally do all of this within 10, 15 lines of code. So ML is the library, and I'll walk you through where to find it and all of that. So it's so much so that last year, about in January, I live in Atlanta, so we hardly get snow there, right? So my kid was asking me, when is it going to snow? And she would always bug me at 10 years old, when is it going to snow, when is it going to snow? So I said, you know what, you're home from the winter break, early January. I said, why don't I teach you how to write code that you can actually predict when it would snow. And she started writing ECL. Of course, she's good at math, so that had to be a precursor that you have to know math at age 10. But then if everything else became syntax, and she was able to write code, and she was running it on a public cluster, and I get an email from Lexis asking me if my child wanted an internship, they would pay her $20 an hour. And I said that, she's 10 years old, she can't work. When I told her that, they were offering an internship for $20 an hour, she said, but you only pay me a quarter for cleaning my room every week, So if a 10-year-old can do this, I promise you that developers can do this, right? So let's dive into some of the code. I'm about 25 minutes early, so let's get in here. So if you clicked on my Twitter, I'm just going to go there and redirect you. Right, so there is a pinned tweet. Yes, I did mention that I was a musician. I really am. Here's the bit.ly, right? If you click on it, it's going to make you log in. And once you, whoop, it's not sharing my screen here. Okay, wait. There we go. That would help. All right, so there we go. So that's the bit.ly. Once you click on it, it will get you onto a cloud IDE. We don't use Cloud IDE, but I was told that in this lesson, if people didn't have to download anything and code directly from their browser, it would be much easier. We use Visual Code, VS Code. And you download VS Code, install ECL, and there you are. So I'm going to go to the DataSeers FinTech DevCon taxi demo. So obviously, like anybody else, you're going to run a hello world, and I'm going to run my hello world, and you can see that it's compiling. And the reason why it says it's compiling is because it is, it's going to be interesting. Hold on, here we go. It does. That's exactly what it does. It compiles to C++ on the server. And you may not have access to this, but I do. And I can show you what happens on the back end. So you actually have an interface like this where you see anybody that's doing anything. You can actually click on it, and you can see the code that I executed. Right? Obviously, that's what I ran, hello world. And then it actually can walk you through everything that it did, right? So what did it do? Who did it create the work unit for? So think about from a auditing perspective. So you cannot run anything here without being tracked in a way, right? It also gives you all these logs step by step. Right? It says, I'm loading this DLL. I'm starting this process. I'm setting the memory to this, blah, blah, blah. Of course, you can turn all this off. Right? When we run our production code, we obfuscate everything so you can't see it. But it's going to tell you step by step what is it going to do. And why is it important? It is important because when you have performance things that you're looking into or anything like that, you can dive into this and look at where specifically the code is slowing down. Now, I haven't seen any other technology give me this level of detail on what's happening. It will tell you about disk speeds, memory clogs, and all of that. And I'll show you some of it. So let's go back and run another one, right? So let's run the dedupe, right? So remember I told you that we have a data set, right? So here's a data set. And I'm going to read my data set, and I'm going to output the data set as taxi. Then I'm going to dedupe the data set, and I'm going to re-output the data set, right? So let's run that. It's compiling, and it's running now. So obviously, one other thing to know is this is a very small cluster, and the data is large, so it might take a couple of seconds to run. And when you go to the output, you actually see that that's how many records exist in the original data set, and that's how many it deduped with one line of command, right? So this is one of the most amazing things that we use in our thing, and it'll show you what the inputs were used. So that's what I used, right? And then if you go into more details of what exactly happened, it's going to walk you through everything it did, right? So it's going to tell you that I read data, I read 58 million records, I grouped them, then I deduped, right? And then after the dedupe, right, before the dedupe I had 58 million, 050. After that I had 58 million, 045. And then I passed it, I counted it, and I just stored it in result 2. So it actually gives you all this detail. Now, if you want to go into more details, you can actually see what happened inside. You can see how many number of rows it processed, what was the average, and there's more here. So how long it took to do the count, right? This is how much it took to count. 24 milliseconds to read the data from the disk, 4 milliseconds to group it, 13 milliseconds to dedupe it. Now, obviously, when we do our stuff, right? I mean, this sounds perfectly fine. 13 milliseconds is nothing, but when you work with 40 billion, 50 billion records, every millisecond counts. So we constantly are working on getting these counts down. But this tells you exactly where the time is going and what you are doing. Now, one of the most amazing things that these guys have done, and I have pre-run a work unit for you, but I'm going to show you what I did. So if you look at what I did here, right, is I took the data set, and this is the data set, and I literally profiled it, right? Just ran a profile on it, literally data patterns.profile and data set. When you actually look at the output, right, it's actually telling me what the attribute is, what is the attribute type, what is the best attribute. So the compiler is telling you that you're using a wrong data type and you should actually change it. It's telling you how many records out of those this is filled, right? It's 100% fill rate. In this case, it's 99.98% fill rate. What is the cardinality? And it actually gives you a lot more information about the patterns and examples and this and that. Why is this useful? Think about doing machine learning and AI. There is so many people out here that I went to who talk about AI, right? And while it's awesome to have data science and machine learning and AI, there's one key element to it is the actual data. If your data is not good, then nothing else matters, right? That's why our company is named Data Seers. We're not fraudfighters.ai. We are Data Seers. The reason why is because it's all about the data. You can take that data and turn it whichever way you want. So something like this, where a processor sends me the data, let's pick on somebody, let's pick on one of the largest guys. Let's say FIS sends me some data. Not that they do this, but I'm just saying if they sent me data and let's say SSN is missing, I can run this profile and I can literally take the fill rate and say, hey, you haven't sent me SSNs. And here is proof you haven't, right? So this literally, and if you see how long it took to run that, it actually shows you. This is 8 seconds of cluster time. So it's actually 3 to 4 seconds. And how many records were there? 5 million something, right? So to run 5 million record profile, it took 4 actual seconds, 8 cluster seconds. So it's pretty wicked fast. And it does a lot of analysis when it looks through all of this, right? So again, the idea is that you can very quickly, you're able to run these profiles and do some basic operations. So I ran another work unit here to show you some basic operations. So all I did was, there we go. All I did was min, max, average, count, right? And if you look at, again, 5 million record data set, 9 milliseconds, that's the cluster time, right? And the internet here is slow, so it's taking a minute to load. There we go. Calculated all of these things for me very fast. So this is literally what Hpcc stands for, and it is now completely cloud native. Yes, it took them a while, because as you can imagine, large companies, when they have 40 petabytes of data, 50 petabytes of data, you don't just wake up and say, I'm going to go to cloud, because only one thing happens, right? Bezos gets richer. And there's nothing else that happens. You end up paying so much money. So it took them a while to finally actually start putting everything in the cloud from that perspective. But they didn't have to. I mean, we don't run in a cloud. We have our own infrastructure. We actually run plain old servers. And why? It's because it's extremely cheap to run an Hpcc cluster. Truly free, so there is no licensing costs of any sort. They have a very active development cycle, so I'll walk you through where you can find all of these. All right, so if you go, this is literally your entire source, right? You can extend it, you can fork it, you can tweak it, right? There's obviously very active development cycle going on. There's a lot of people that work on it. And the beauty is, People asked me when we first started doing Hpcc 4.5 years ago, a lot of people asked us, what happens if Hpcc goes away? That's like saying, what happens if all of our identity data disappears? It's not going to go away because it's being used in one of the largest financial services use cases in the world. And look at how active that development cycle is. So you want something done, you don't like a functionality, you want something seen. So I'll give an example. JWT did not exist in Hpcc systems because JWT is more modern and their authentication mechanisms were old. So we actually made a request saying, guys, come on, you got to support JWT. And they actually coded it and gave it to us. How many times in your life you have actually worked with an open source community like this where you actually want a functionality and they develop it within your timeline? They'll say, oh yeah, 2 years from now, we have a lot going on, right? So that's the key of Hpcc now. And this guy, by the way, Richard Chapman, he's pretty much the #1 guy developing this entire platform for the past 20 years. So they're very active. So if you go there, you'll find a lot of examples, right? So there are ECL bundles. There is a lot of different things they do here. They actually have some pretty interesting comparisons. So they actually have a Hadoop connector. They actually have a Spark connector. And the reason why they do that is because compared to HDFS and Hpcc's file system, Hpcc file system performs much better. So they're saying, why don't you use Spark, but store the data in Hpcc? Because it's much better to handle the data there. So one of the things I will tell you is if you go to the IDE, and if you look at, there is a ECL samples, you'll have all these training, or even better, go here and type there we go, ECL training, okay? This is the entire New York taxi data, okay, that I'm talking about. It talks from data ingestion, data profiling, data validation, data enhancement. It actually does some linear and logistic regression as well. And then, this is the most amazing thing, I like to keep it, is how to do your syntax, right? So if you're doing something data set, here's an example. So sometimes people forget the syntax. So that's the easiest way to keep track of the cheat sheet. So I know there's a big PDF document here that you can print, and I wish I had printed it beforehand to give it to you guys, but it will load. I think the internet here is a little bit slow. But that's the idea. So again, 30 minutes of talk. I know I have gone a little bit over. Do you guys want to get your hands dirty? You don't have to if you don't want to. If you would like, I will be available later, even after this conference. And forget me, Lexis actually has a community on Hpcc systems, which can actually help you get started. So look at it as one of the tools that is totally 100% free and that you can use to develop your projects. Does anybody have any questions? Yes?
Do you control how parallel it goes, or will it always be like maximum parallelization?
Do I control what? Sorry.
How parallelized the cluster runs?
How parallel the cluster runs? You can, but you shouldn't, right? Because when you write a piece of code and when it's going to take it to all these little slaves and do its job, the idea is that why do you want to meddle with it, right? Now, there are use cases that we will do, and I can show you some of it, actually, what happens there. So if you go to Profile, and I go to Graphs, and I click on that graph. All right, so you see that it's a crazy graph, right? It's telling me everything exactly it did from the start. And one of the things we look for in here, right, obviously it's very hard to read, but let's go here, okay? So it's basically, it has 26 million records, and that 1.03/1.03 means how skewed the data is. One of the most important concepts of big data, and when we are working with clustered environments, is if you have 40 slaves that are doing a job. So it's like saying, let's say you have 40 employees who are doing job. Not saying that the employees are slaves, but you have 40 employees that are doing the job, but you ended up giving all the work to one of your employees, and the other 39 had nothing to do. What would happen? It would be tremendously slow, right? That's what happens in Hpcc, where sometimes the parallelism, depending upon how your data set is organized, it may end up skewed on a few slaves more than the others. And if that happens, it does affect parallelization. So that's why when I showed you an example earlier of dedupe, remember I said sort it first and then dedupe it? It's almost always faster. Why? Because all of this is really a B tree. If your data is sorted really well, the B tree is going to run fast. So that's how all of this affects, right? So you get into stuff, and you see here some of these skews are starting to already look better, because they're like tiny. And you'll always have tiny skews, right? The reason is because, let's put it this way. You have 101 records and 10 slaves to do the job. Some guy is going to have 11 records. Everybody may have 10, but one guy is going to have 11. And so your data is always going to be skewed. So skew is a natural part of what you do and when you distribute the data. But the key is to be able to distribute the data as evenly as you can. See, here is a little bit of a bigger skew, right? So you see 5% skew. So those are the things that make the parallelism slow or fast. And that's basically what you always end up working on. After you write the code, is make sure it's evenly distributed, especially when you're working with billions of records.
So the concept of spraying, does that need to be done previous to each workload that you execute?
That's a great question. No. So usually when you spray the file, what you're saying is, I have this CSV file, and it's a single part, one part CSV file or whatever file it is. Once you spray, you're basically saying, without me telling you anything, take this file, split it up into 40 ways so that I can use the power of the cluster. So you just do it once, right? When you get the data. So the one thing we do is we get hundreds of files containing multiple gigabytes of data every day. The very first thing we do when we get the file is we spray it. Once it's sprayed, it's done. Now I can manipulate it however I want it. Now if I don't like it, I can reject it back. And there is, just like there is a concept of spray, there is also a concept of despray. So it's taking a file from your folder and injecting it into the cluster. And then despray is the concept of pulling it back and putting it into the file system. So when we have to send a file out, we would despray. When we get a file in, we would spray. But it's just once. And once it's sprayed, it's ready to be used. Any questions?
Have you used it more like online system rather than like offline processing, where it's like part of application, where like you're not doing analysis after the fact. It's more in process in terms of the workflow.
Are you asking about? I mean, it's hard to hear you because of the mask. But is it? Are you asking about more real time versus batch?
Yeah, and work with use cases where like some of the data that's being processed needs to get back into a UI.
Correct. So, great question, right? And one of the other things I will tell you, right? People are running some jobs. One thing I will tell you, and I apologize I didn't tell earlier. You see these two names, HTOR and TOR, right? So pick a TOR cluster. When you pick a TOR cluster, you'll actually run fast. When you go HTOR, it's actually a single-threaded TOR. So it will run slow, right? And Roxy is where your indexes are. So that's why index is not running. Now, if you want to see what he did wrong, right? So it said module taxi data does not export an attribute main. So let's go look at it, right? So this is, you can't run this. The reason is because there is no action. This is a definition of a record set, but there is no action to it, meaning you're not telling the computer what to do or the compiler what to do. This is just saying that this is my record set and this is my module. So if you create another file and say import taxi data and then use the taxidata.rec and output it, it'll actually work. So UI. When this system was developed, it was really meant for developers, right? Hence, talking about it at FinTech DevCon. This is the UI that it produced at first. And this UI has been like this forever, right? And it it's changing in many ways, but it's really very useful. But you can develop any UI that you want that goes in front of this because everything is web services driven, right? So if you actually snoop around and see what's happening, right, and go into your, it opened here, hold on. There we go, and you look at network, and if I were to refresh this page again, right, there's a lot of these, APIs that are being called, set, fetch, this, that, and you can use any of that to write your own front-end UI. So we, as a company, have added a lot of, front-end to Hpcc. So it's like a database, right? It's like having MySQL, and MySQL has a basic front-end, but that doesn't translate into business data. Now, the other thing you brought up, an important question of whether or not batch versus real time. So let's talk about that. So any database typically is designed for batch. Why? Because of dirty reads, right? The data has to commit before you can read it. Otherwise, it's considered dirty reads. So same thing applies here. The data has to be committed somewhere before me to read it. Because if you have transient data, the assumption is that data can change, and then I don't want to rely on it. But they have been successfully able to use a real-time use case, like I said, for the flight tracking or the Fitbit on cows. I mean, our clients actually integrate us real-time into their mobile applications. And when people are transferring money, they will actually send that data here in real time. And in real time, we can actually tell them whether it's fraud or not, right? And all of that is happening in real time. We just do it on the Roxy side, not on the Thor side, because Thor is about manipulating large data sets, and Roxy is about fast indexing. So when you want to run a 10,000 connections at the same time, 10,000 transactions coming in at the same time, you'll just do it on the Roxy cluster, whereas Thor is more for data analytics and analysis and all of that. You can also do UI, meaning you can actually output graphs and charts and all of that in here as well. Any other questions?
Just kind of an open-ended question
Yep.
here. Forgive me for this. So one of the things that we do is we ingest billions of transaction records from, let's say, Yodlee and X, things like that. Try to make sense of these transactions and trends and do performance analytics and whatnot. So obviously something like this is very attractive. We run in AWS, so I don't believe, last I looked at RDS, there wasn't an Hpcc cluster that you could spin up. So it sounds like you would just spin up some EC2 servers and then install this.
Pretty much. I think I'm not sure. Let's look at this, right? I thought they were. Yeah, they are out there, right? Oh, a version has been removed and this version has been removed and no longer available for customers. I don't know, but there is a new version that has come out. So here's the thing, though. Let's say you don't have this, available. Just download it on your machine.
Right.
As long as you have storage, hard drive storage, you don't need any powerful machine to run this. It can run on my laptop with everything. So, but I think they have moved more towards Azure, I want to say. But you can definitely spin it up. And here's the other thing. If you have CentOS or Ubuntu, whatever you are using, download their image, and within 30 seconds, you'll be able to install it. It's literally just, install that, not image, but install their package, and you're done. Or you download an image, you can mount that image, and they already have images on their website. And there's a ton of training material too, by the way. So if you go, I have never seen anybody being so open about, And there is a event coming up, by the way. See, they have been now open sourced 10 years. And they have a lot of, you can literally go download the Hpcc Systems platform. And, you can choose your operating system, right, whatever it is, and it's literally, there you go. It gives you the whole platform, and anything else you want. So there is support for Couchbase. Huh? It's tiny. Yeah, it's tiny. So, and then you have all these connectors, right? You can actually use Couchbase, Java, Kafka, MySQL, Redis, SQLite, all of these things, there are plugins. And you can also download a virtual box, and there is all these trainings, videos, classes, white papers. There is a community. There is a bunch of tech talks. There is actually an event coming up soon. I think it's in a month, sometime in October, where all the developers come around. Of course, Plexus and its affiliates use HPC system a lot, but there is a lot of academic use cases out there. And the new 8.0.0 is completely cloud native, uses Kubernetes and other things. So it's much faster and much better than what the previous versions were. It's completely re-engineered. Any other questions? Yes. Absolutely, let's do it. Let's do it. That was the purpose here. So go into the Cloud IDE. If you guys have not been able to get there, let me know. And you should basically get access to all of these. So start playing with it. Yes?
Sorry to interrupt.
No.
For me, I just see the ECL samples.
Okay, hold on. You see the ECL samples, got it. So let me make sure I went in and clicked the link again. Okay. Yeah. So this is new for me, I must admit it. Before I came here, I was not able to get any of this up and running, so I was working with the guys saying, what is this? This is new for me. I have never used this. They are trying to create this web-based IDE to make people's life easy. If you just want to play with it, the idea is not that you're going to use this for the rest of your lives. You're going to actually use VS Code. But to get it up and running in a session like this is the easiest, because this is being taught today in universities across the country. So DataSeries is actually doing an exercise where we are teaching this to younger kids, maybe out of high school or early college, so that they can get educated. Because Python is Python, it's great, don't get me wrong. But this is a much different animal. Did you get in?
Yeah, that works.
Okay, cool. And then as you guys are running here, I can see these. There we go. Who is Santiago, by the way? Oh, yeah. Awesome. Are you Sam?
Yeah.
There we go. So yeah, start running just come up with, who is David? There we go. Yeah, see? The one thing I will tell you is go to the earlier link that I had, where you had the Hpcc cheat sheet, this one, right? Because you'll actually see specific examples. Let's say you want to do some linear regression. The cheat sheet will tell you the specific syntax and commands. So if you guys have a specific project in mind, let's say, why don't we do this? Why don't we let's look at the data first, and I'll give you an exercise, and we'll do that. How about that? All right, so this is my data. All right, here we go. Let's see if I have a pickup latitude, longitude. Okay, so let's do this, right? So can we run some code that says what was the min, max, and average fare of the taxi for any ride that had more than 2 passengers? Let's try to see if we can do that, right? So you already have an example of min, max, and average in my sample. So the simplest thing would be to do that for anybody who had greater than 2 passengers. And I'll give you a hint. So if you go to the cheat sheet, you should be able to see. See, this is not loading for me. Does this guy load for you guys? It's not loading for me here. I don't know why. Maybe I should download it. There we go. That's probably what it was. There you go. This actually tells you a lot about how you can play with it. So So the answer is in here, believe it or not, right? It's just that, can you do it? Can you filter the data set? So all you need to do is filter it. Let's see who gets it first. Maybe they win a t-shirt, right? And if you can't get it in 5 minutes or maybe 3 minutes, I'll give it to you.
I think you can run the cluster across multiple machines.
You can, yes, you can. So Hpcc can virtualize within a single box or across multiple boxes. The thing that you have to think about, though, when you do that is when you have multiple physical boxes running, you're going to have network latency, right? When you're shuffling data across from one machine to the other machine to the other machine, you got to think how much data are you shuffling. So when everything is running on a single box, you have a limitation that that box goes down. What do you do? Versus, you have multiple boxes, but there is data latency because you're transferring. So the answer is yes. It will run however you want it to run, wherever you want it to run.
Does it go away if you spray the data?
No. So this is another thing. When you spray, and this happens to us many times, right? So let's say you have a client that says, hey, I'm going to send 10 million records to you, 10 billion, let's say, right? Great. You set up a cluster, you spray the data, and it's maybe split into 50 ways. Well, guess what? The client slightly underestimated and gave you 60 billion records instead of 10. Obviously, you need a larger cluster, but you already sprayed the data. Now what? Well, you can actually have the cluster still read that data and then redistribute it to all these little slaves. So at no point of time you're stuck. You can expand it and grow with the data as much as you want. And we do that pretty much daily. So every night we run a roll-up, we redistribute the data so that we make sure that it's always crisp and fast. But this is always our most up-to-date engine. And even when real-time data comes into us, at some point of time it goes in here because this is where machine learning happens, right? So. Did it run? Did it give us a result? Nope. How about I tell you, and then the next one you do. All I need to know is the, passenger underscore count. So, here. Yes, 1 second. Version number error? That's fine. Yeah, the ECL IDE is actually running, I think, 7 something, and this cluster is running the latest. Question, yes?
What's the easiest way, at least as a beginner, to see what the data looks like? What are the columns?
Sure. So the easiest way is you actually go to this URL, right? And that's why I said the IDE is very basic. So one thing you could do, and I'll show you what you can do. So before I go there, though, let me show you what happened here, right? So all I did was I wanted to do the same thing. Oops, come on. Why did it not output anything? That's weird. I think the internet here is making it hard for me to get to anything, so it's not even responding right now. So let me answer your question while it's doing that. So taxi data, okay? So this is your data set, right? So in the count sample, where I did output count, why don't we just output the data set like that, right? Instead of the count. And what's going to happen is it's going to, something went wrong back there, hold on. I think this is all frozen, there we go. Yeah, see? data set too large to output, right? So what I'm going to do now is I think there is a, I want to say there is a keyword. So when I started this company, I used to be really good at ECL, and then I forgot most of my syntaxes. So let's do this, hold on. Choosing. And let's try that. And I think this is why I like my ECL cheat sheet, right? So in here, this is an output, and you will see somewhere there will be a chosen. Somewhere here, there should be a, here we go, right? So chosen, whatever data set, comma 2. So let's do that, right? And now it will run 100 rows, and that's your data set. And it shows it up here too, by the way, right? In your IDE, it will show you what the columns are. But what I have done beforehand is in this taxi data, I've actually told you all the different columns that are in here. So just remember, when you do this on your own, you're going to have access to ECL Watch. This is where you're going to see your data. This is where you're going to see what's happening, right? There we go. Oh, sorry, hold on. Close. I want to see my basic operations. There we go. That was what I ran earlier with the filter on. Can I give you another example? Maybe another exercise to do, simple. Let's see. Let's look at the data again. And okay. And this is, okay. Can you tell me how many rides were greater than 5 miles? And for those people who came late, if you guys want to still play with it, go to my Twitter handle, Adwait Joshi. There is a link, bit.ly, and you'll jump right into ECL IDE. More than 5 miles. Yep, how many people took rides, or how many rides were more than 5 miles? And let me know when you think you have it so I can pull up the results. One thing to remember in ECL, it almost doesn't matter the order of things you do. So let's say you have output. It's almost no telling which will go first. The compiler will decide what's quickest, and it'll figure it out. Yes?
Should I tell you what I think it is? Or?
Well, run it.
Oh, well, I did just run it.
Which one is it?
It should be
It'll give you a number.
basic operations.
Sam?
Yeah.
All right. So let's see. So 8 million out of 50 million rides? Let's see. There we go. That's it, right? That's right. It's as simple as that, right? Now, let's do a little bit more complex than that, right? Yeah. Right there. So it's just take the data set, trip distance greater than 5.
So there's really not tables. Is there a concept of joining to another data set?
Yes, there is. So that's a good question. Now, what I need to do is see what data I have so that I can show you. Okay, so he has weather data, okay? But he hasn't sprayed it. Okay, let's see if we can actually wait. Yeah. There we go. Let's spray it. Okay, and come on. So this, I think, is a, yeah, see, so this is a delimited file, not delimited file, but a fixed width file. So let me see what it is so that I can read it properly. Unless I have, come on, unless I have a cheat sheet already for New York Taxi to read the data. So I may. No. Mouse.
Is it pretty easy to load data into this then?
Yes, you can actually upload your own data set. You go to files and landing zones, and you can literally upload your own data set. I don't know why this is so lagging, but you can upload data set, you can see whatever you want, and you can just upload it, and it'll show up here. And once it's there, you just spray the data set, and then it's ready to use. So I'm looking at, see, this is the file.
This is part of the Hpcc package.
Yes, so there's two ways to load the files. One is obviously when you're playing with it, you just go there, upload the file, spray it. It's standard part of the Hpcc package. Or you can do it programmatically. So obviously when we get hundreds of thousands of files, we don't upload it manually. So it's all programmatically done. So let's see if I can figure out what is my column. So that looks like a date. Don't know what that is. We can make something up and we can try to, or I can actually show you how to join on a table. How about that? So I take the exact data set and I break it apart, right? So let's say, okay. And then I say DS1 is my data set 1. I'm going to do table, and I'm going to do taxi data. And let's pick a couple columns. How about that? So we create our own data set, and we break it apart. So I'm trying to see what is going to be a good join key. Yeah, but it's repeated, right? So that's why I was like, maybe vendor ID and passenger count, maybe, or maybe vendor ID, passenger count, and trip distance. I don't know. Those, let's just use that as a key. How about that? Vendor ID, passenger count, trip distance. Okay, so. And then use, did we have latitude, longitudes of some sort, right? Yep, pick up longitude, pick up latitude. There we go. Let's just use that for now. And this is pretty much case insensitive, so it doesn't matter what you type. All right, so let me see one thing here. Okay, then I am going to take a second data set. Oop, where's my mouse? There we go. And let's pick something else. So what columns do we want? Let's say drop off, right? Okay, just for my sanity, I'm going to make sure that my data sets are right. So I'm going to output that. I'm going to say DS1, 100, and I'm going to say it's called as DS1, right? Otherwise, it'll just say result 1. So I just want to give it a name. And then I will output my DS2 and name it as DS2. So if everything is right, at least I should have my, right, boom. Ooh, it doesn't like that. So, okay, let's try it again. It doesn't like that still. So let's see why it doesn't like it.
Is it the capital A in taxi data?
Nah. I'm missing, oh, passenger. There we go. Now what happens when you don't look? What else is wrong? Vendor ID, passenger count, trip distance, pickup longitude, pickup latitude. I'm missing something clearly here. Nope. Nope, passenger count, trip distance. Huh?
I thought I saw something.
No, something's wrong. Hold on. And this is why I don't like the IDE, because it doesn't give you. Oh, I know why. Oop, I know why. I'm missing something here. It's going to make me do a. Okay, let's pick. Okay, let's do it by. I'm just going to group it by something that way it will get me some data. Hold on. Again, what was my rate code ID? There we go. Let's do that. Still doesn't like me. Do I have something missing there? I can't see it. No. Well, let's do something else, okay? Here's another way of doing it. I'll show you this. Because it doesn't like my tables, we are going to do something different. So here's how you do a join, okay? Instead of doing a traditional join, what I'll do is I'll filter and join two tables, right? So let's say dataset join. Oop, there we go. Okay, equals. So you do join, then your. Okay, and I will say trip distance greater than 5 is one of my data set. Okay, and I'll do taxi data. And I'll say trip distance less than 5 is my second data set. Okay, then you start joining based on, let's say, left dot vendor ID equals right dot vendor ID, and whatever you want to do, right? And left dot passenger count equals right dot passenger count. Okay, just a simple basic. Now, so you gave two data sets, a left data set, a right data set. You gave it a join condition. Now you're going to tell it what do you want back. Okay, so I'm going to do that. I'm going to say transform. And then I'm going to say, since in our case, both the left and the right record sets are really the same, I'm going to say record of, okay, taxi data Then I'm going to say, if I want anything else coming out of here, so I'll say self.left, self colon equals left. Okay, so what happens here when you do self colon equals left? So when you say record off, it is just creating a record set that is of that type, okay? So let's create another data set just for the heck of it. Where's my mouse? There we go. Okay, I'm going to copy this. I'm going to create a new data set. I'm going to call it taxi data new, okay? I will copy this, and I will remove some things from here, okay? So let's say I want to remove longitudes, and I want to remove latitudes. Okay, so my data set now is different than the original taxi data set. So what happens here is if I say taxi data new, and I want to import that as well. What's now going on is it's going to return back to me a new data set. But what do you want to populate? What priority do you want to give it? I'm saying self equals left, which means if there is anything in here that name matches a column of anything on the left-hand side, take the left side rather than the right side. So it will give a preference to the left-hand side data set. That's all it means. And then you close your transform and then say what type of join do you want? Inner. And then you can just output. Right? That's it. So that's your join. And again, if you go to your Hpcc training and go back into your New York taxi trip data, you'll probably find enough examples for join here as well, right? So that's basically how a join syntax looks like. So you have a left data set, you have your right data set, your join condition, and what do you want? So in short, in SQL, you would have said select all these fields, right, from this table, inner join this table on this condition, right? So instead of that, that's your syntax.
Are there also unions, intersections?
Nope. I don't know why it's not liking. This is an IDE issue, not my code issue, I promise you. It doesn't even like importing my STD, which is a standard library. But no, there is no intersections, there is no unions, mainly because if you want, okay, let me show you something. Let me actually go back here. Count sample, okay? I'm going to do something crazy here. All right, you have DS taxi, right? So you said union. So you know what it's doing right now? It's actually joining those two data sets, creating a double copy and outputting it. So that's your union right there. You can take two data sets and just say plus. You want to subtract two data sets, you have something that you want to get off of it, you say minus. I mean, obviously, taking 50 million records and adding them together, there you go. So 58 million and then 116 million. So now you have a double data set. So that's your union. You can, intersection would work the same way. You would have to basically, instead of doing an intersection, you would end up doing like kind of a join, basically. And the joins are really fancy because you have different types of joins as well. So in the ECL cheat sheet, if you look for join, they should talk about all different kinds of joins, right? So here. So They're doing, and see, this is another example. So we can actually take this example directly, and we can literally create all of whatever we want to do. These examples will self-run, meaning you don't need external data. You can just run them as is. And so what happens in this is when you run, see, they're creating a data set inline, right, based on the layout. And so that's basically what these samples will help you do. Is they'll help you sort, they'll help you join, they'll help you run some basic functions, and so on and so forth. Group them, right? Do some statistics. This is a great tool. And here's your 2 data sets that they're changing, right? They're converting some from string to date, and so on and so forth. Let's see. You said how many attribute you mean to say people who took more than 5 miles? Eight, yeah, that's it. This is the right number. It's the right number. Yeah. Yep. So, I mean, this is really, really simple. I mean, I can't, listen, I literally started DataSeers 4.5 years ago, and I wrote some of our first code, and I was telling, when they told me that they wanted me to teach a class, actually my VP of engineering happens to be in Colorado right now. She's just in Boulder. Otherwise, I would have called her to do the lesson here. And she's pretty young and has taken this on a whole different level. To give you an example of how HPCC runs today, when you get an ACH in from the Federal Reserve, every day you get all these files and money coming to people. We sit in between the Federal Reserve and the banks, and we are processing that ACH in real time. That's the power, and we are sending tens of millions of transactions through. And obviously, we are fraud scoring and risk scoring and all of that. So if you want to play more, you can actually go to this cheat sheet and start running all of these examples. And you will see that they will run in line. See here, this is actually better. Let me walk through this. I didn't even realize that he had done this. See? So they have given me a data set. Okay, let's copy that. And let's take it here. Let's create new. There we go. So now what has happened is you have a very basic trip data set and a weather data set, and we can just use one of the join conditions here, right? There you go. So now here's a funny thing. I did not even tell it what to do. I just said join the 2 data sets, but I did not even tell the compiler what to do. This is what I mean by the compiler said, oh, okay, you're joining the data sets, but you're most likely joining them because you want to see the combined data. That's why it outputted the combined data for me. So this is what I mean by the compiler is very forgiving. You may make a mistake. Clearly, in that case, there was a mistake, but it didn't care. It just gave me whatever I wanted to see anyways. Any other questions? This is fun, guys. So listen, if you decide that this is something that you want to do, please let me know. I can actually put you in touch with the trainers as well. They can give you free training. They can help you learn this technology, and this comes directly from Hpcc systems. They can help you understand the cluster. There is a conference coming, developer conference for Hpcc systems, and I can get you passes for it. It's virtual, so you can sit at the comfort of your home and listen to the sessions. My VP of engineering will be talking. My chief operations officer will be talking. They're actually going to be talking about how we solve some of the problems, like in the cryptocurrency space, for example. What do we do in order to solve crypto issues and fraud issues? So if there is anything you need, let me know. But other than that, I think I can give you guys back some 6 odd minutes back. And there is t-shirts here. Please take them. I'm not going to take them back, I promise you. There is some pens, orange colored pens. No problem. No problem. And yeah, so if you go to the website, right, again, and if you go to download, you can actually download the VM, right, the entire VM. So it's everything is, configured for you. So once you install this, it's good to go. Just download VirtualBox from Oracle, mount it, and this one is a little bit big, right, obviously, because it comes, I think there is some data in there as well, but the whole operating system is there. So, and just boom. And you can go old versions too, and there is literally training videos there. There is online training, walk through how the system runs. I mean, once you get beyond coding and you start doing maintenance on this, it's pretty interesting because, that's where we tweak the system to run even faster. That's when you start getting into block sizes and how the files are written and hardware optimization and all of that. But everything out of the box you need is here. All the concepts training, it's all open source. And there is a developer community. So here we go. Talk about joins and transforms, basic joins, sort and dedupe, aggregated data sets, everything is here. And there is a forum, which, again, you can ask questions, and, it's pretty active.
I'm trying to understand in my mind why, I've heard of Hpcc, but I'm trying to understand, this is like a very well-kept secret.
It is, and I always say that, let's see why. So when, again, I can only guess, but when the company was acquired, it was acquired because of a specific competition that existed in the industry. If they would have given it to everybody, then they would have lost the competitive edge. I think there was a big decision. I mean, some of the early people, they had to make a big decision. I mean, LexisNexis is a big company, and you don't just wake up one day and say, okay, I want all of this open source, right? There's a lot of thought process that goes behind it. So it took years, and ever since it has gone public, more and more people are using it very actively. And they will continue to, because there is a whole group of folks that is teaching this in schools now. And so it is the best kept secret, and it was the best kept secret because of how it evolved. Any other questions?
Thank you very much.
Cool. Well, thank you. Awesome.
Very good. Very, very good.
Thank
you
you.
so much. And
Ooh, Florida State College.